A very good evening to all of you. Welcome to ANB Exam Forum. So student, we have started special 1 hour classes for mathematics, and in today we will see the set theory part 2. Part 1 we have already covered, where we discuss about the set, various notation, various representation and the different type of sets. Okay, so in today's session we are going to see the operations and the Venn diagram. Okay, so before starting this session, I would like to tell you that we have made various videos on general awareness, like 5 PYQs a day, and we have made a dedicated playlist for computer awareness. Okay, so you can watch those videos and get benefited from them. So as I told you earlier, that we have already covered the basic of sets, like what are the different types of set. Okay, so in today's session we are going to see the operation like union, intersection, difference and complement, along with the Venn diagrams. Okay, and we will also see PYQs related to these topics so that you can have a better understanding of all these topics. Okay, so one small request to get benefited from this session, like first answer with us. Okay, so as soon as you got this question on the screen, you try to answer with us. Okay, you can answer in the chat box or the comment, whatever you feel. Okay, and most importantly, note down the important points which you don't know. Okay, so this will be very beneficial for your reinforcement of the learning. Okay, so let's begin it. And we have already seen the representation and the different type of sets in the previous video, and in today's video we are going to see the various operations on set. What are the various operations on set? And as you have already read in your classes, like union, intersection, difference, complement, these are the basic 4 operations which are performed in the set theory. And we will also try to see their properties. Again, it is very important to see their behavior. Okay, so this is one other video, okay, on the statistic part. Okay, so coming to the first and foremost operation is the union. Okay, union of sets. Okay, as the word suggests, union means which combines, okay, which includes, okay, which joins, is basically a union. Okay, as if you see the Venn diagram for this union, it is very simple one. U stand for universal set, and this is denoted by box, and this circle is set A, this circle is set B. There are obviously few elements which are common in both, and this blue portion denotes A union B. Okay, theoretically, how to put that? The union of two sets A and B is the set C. Okay, so we will have set C, obviously new set will be made, which have all the elements which are either in A or in B or in both. Okay, this is a common portion, which is another terminology called intersection, which we are going to see in the next slide. Okay, so definition, remember student, A union B is set of all x which x belongs to A or x belongs to B. Okay, which either belongs to set A or it belongs to set B, and obviously there will be common element in between them. Okay, let's see the properties of this operation. There are basically many properties, but these 4 properties are very important. First is commutative law. As you have seen in the numbers part also, commutative means what? If A is union of B, then B is union of A. And if you go back, if I am saying A is union of B, B is union of A, it means the same thing, right? The second one is associative. Associative law also holds. A is A union B union C. If you group in 2 separate way, then again this law holds. Law of identity. This I already told you, it is a null set, empty set, and if you are adding an empty set in another set with the union operation, you will get the same set. Why? Because there is no element in it. Okay, so this is called identity element. Okay, the next one is idempotent law. Idempotent means if you are unioning one set with the same set, you will get the same set. Obviously there is no new element added to it, so you will get the same element. And this is important. If you are union with the universal set, obviously universal is bigger than the proper set, so you will have union after the union of the universal set. This is called law of universal set. Okay, and this law, as I told you, can be verified with the help of Venn diagram. This is a very simple one, and they will not be asked in exam, but definitely they will be helpful during simplification of the laws. Okay, the second operation is the intersection of set. Okay, as we have seen in union, all these portions are included, but in intersection the common elements will be taken out. Okay, so it is basically a set of all those elements which belongs to both A and both B. So this portion denote the elements which are present in both A as well as both B. Okay, and by definition it is like this: A intersection of B, it means X is either belongs to A and X belongs to B. Whereas if you go to the union, it is OR, but here it is and means it should be in both of the set. Okay, properties I will not repeat, it is similar to the union. Okay, but distributive law, one more is there, because it always operate in either way, like union intersection. If intersection is in front of the bracket, then first these two will be taken, like A intersection B, then union operation will be taken, and again A intersection will be taken. Like this intersection is distributing over these two sets. This is similar to the numbers that we have seen, and this law can be verified with the help of Venn diagram. Yes, you're right. Coming to the next operation, that is disjoint set. It is basically not a operation. It means like you have two sets and there are no common element between them, then these two sets are called disjoint set. Okay, and if two sets are disjoint, what does this means? That there is no common element between them, and common element is denoted by intersection. So A intersection B will be an empty set. This is phi is empty set and null set. Okay, just remember this word disjoint set. Coming to the difference of sets, we have already seen like this total is A union B, and difference means what? All the elements which belong to set A. Actually it depends. Okay, if you have A minus B, what does this means? Like what are the elements which are present in A but not in B? So it is also excluding all those elements which are common to both. Okay, like if you say A minus B include only this portion. This intersection portion will not be there. Okay, basically it is a difference of set. Again, this white portion denotes B minus A, the elements which are present in B but not in A, including the common one. Okay, so like if you see the definition, X belongs to A and X does not belong to B. Okay, so all the elements which belongs to only A but not B. Okay, so obviously the common element will not be in the difference of set. And a very common operation that A minus B will now never be equal to B minus A, because this is B minus A, this will be A minus B. So how can be they equal, right? Coming to the next operation, which is complement of sets. So a very simple one. So you have set A and this is universal of set. So if switch over, like instead of considering this set, you are considering all the other elements which are present in the universal set are called complement. Okay, so if you see the definition, it is set of all the element of U which are not the element of A. Okay, it is set of all the elements which are present in the universal set, like all these elements which are present in universal set which are not in this particular set is known as complement of set. Understood? Like if you see the definition, a complement means X belongs to universal set but X does not belong to this particular set. Obviously the complement of A will be U minus A, the element which are present in U but not in A. So this is again one property of the complement of set. Okay, if you see the property of complement, the important is De Morgan's law. Like complement of A union B will be A complement, this complement will come here, this complement will come here, and this sign will be reversed. Okay, so it will be A complement intersection B complement. Okay, and the law of double complementation means if you have two complement, it will be nullified. Okay, so you will have set A only. Okay, so all these laws which are given in this slide can be verified with the help of Venn diagram. Okay, the first question, it is on your screen. So there are several notations in this question. So if you don't know about the basic of set theory, you should go back and study that chapter and come back to this video, otherwise you will not gain anything. Okay, so basically the question says there are three set x, y, z and this operation is given. You need to tell what will be the simplification of this operation. Okay, this is very simple one, a very easy one. So like x intersection y. Okay, x intersection y means what are the common element between x and y. So if you see x and y, the common element between these two is only c. Only c is common, not b. Why? Because b, as I told you in conceptual classes, b is not equal to this symbol set b. Okay, so this b is not equivalent to set b. This element is not equal to set a. Okay, so only c is common between x and y. Okay, similarly like x intersection y intersection z. Okay, so we have c here and c and this set, what is a common? So since this is a set and c is the element, so those two are not equal, therefore the answer would be null set, because your c is not equal to the set c. Okay, this represent member of set, whereas this represent a set having element c. Okay, and those two are not equal, therefore the common element between these two will be null set. Okay, this is denoted by phi, so option D is the correct answer. Okay, so those who have given option D, well and good, they are right. Let's see the next question. So again there are three sets A, B, C, and in this question you should build the set. Okay, for building the set you can tabulate them. Okay, so let's tabulate one by them. So A will be x is multiple of 7. Okay, so we begin x with 1, so it will be 7, 14, 21. Basically it is a multiplication table of 7. Okay, 7 5 is 35 and so on. Okay, let's tabulate the next set. X is multiple of 5, so let's make the multiplication table of 5, 15, 20 and so on. Let's make the table of 35. It begins with 35, 35 2 is 70 and so on. Okay, so which one of the following is a null set? Okay, so in these type of question where you need to see each and every option, always begin with option D, and most probably option D seems to be the valid one, because examiner also knows that they will do it sequentially, so better start with option D. Let's start with option D. So A intersection B, so what are the common element between A and B? So if you find A intersection B, the common element between A and B, if you see, those are 35 will be the common. If you go on increasing like 25, so 5 7 is 35, so 35 will be common. Then multiple of 5 is 10, So these elements will be the common element between A and B. So this minus C, so C has certain element. So what does this minus operation means? Those which are present in this set but not in C. But if you see, all these are present in C also. So there are no such element which are present in A intersection B but not C. Therefore it is equal to null set. Okay, so the result will be null set. Why? Because every element which are present in A intersection B are also present in set C, and there are no such element which are present in A intersection B but not in C. So therefore the answer is option D. Okay, I know if you don't have the theory portion, you just go back, then you can easily appreciate this solution. Okay, so option D is the right answer. Let's see the next question. So there are basically two set. Again, you need to tell the number of element present in A minus B and B minus A. Student, as I told you, there are several operations like union, intersection, difference. Okay, so this is basically a difference, and difference we have represented like this. So those elements which are present in A but not in B, so this shaded portion is basically A minus B, which are present only in A and not in B. Therefore common element are also not taken inside A minus B. Okay, so this represent A minus B. Okay, so let's see. So those elements which are present in A minus A but not in B, that is A minus B. So those elements which are present in A not in B, so those elements which are present in A but not in B, so 7 is present in B, so we will ignore 8 is not present in B, so this is this will be one element. Okay, and the other would be 9 is also not present in B, 11 is not present in B, 12 is not present in B, whereas if you see 10 is also present in B. So there are 4 elements in A minus B, so 4 element is present in A minus B, so you can simply eliminate option A and C. So you are left with option B and D. So let's see what are the elements present in B minus A. So B minus A means the elements which are present in B but not in A. So the element which are present in B but not in A, what will be that? So so 7 is element is both present in A and B, so 10 is also there. 14 and 15 are not present in A but they are present in B, so it will be 14 and 15. So there are 2 elements which are present in B minus A, so option B is the right answer. Okay, 4 and 2 is the right answer. So those who have given option B, they are right. Let's see the next question. So the question says basically they have said that A is a non-empty set of E. What is the simplification of this? Okay, so let's make it simplify. So A intersection phi is null set. So if anything is intersecting, anything which is common with phi is again a phi, because no elements are common between them, so it will become phi. Okay, and again the element which are present in A but not in phi will obviously be the A only. Okay, since it doesn't have any elements, so all the present elements which are present in A will be only in A, not in phi, so the operation result will be only A. Okay, let me make one bracket for this. Okay, so E union phi, anything with union with phi, you will have the same set. This is a property we have seen, and you have E minus A, and since E is the universal set and universal set minus A is what we have seen the definition, it is complement of A. Okay, so universal set, as I told you in my theory video, that if this is a universal set, this is a set A, so the remaining portion is the complement of A, so we get complement of A as the answer. Here universal set is what? E. Okay, so option B, those who have given, well and good, they are right. Let's see the next question. So basically there are 2 non-empty subset of E, so you need to tell what is the equivalent of this. Student, if you try to solve with the simplification, you will get into trouble, so better to solve with the Venn diagram. So you have set A and set B. Okay, so so A union A intersection B. Okay, so we have two set A and B, so this portion represent A intersection B. Okay, and you are unioning with A intersection B, so A union with A intersection B will become this shaded portion whole, which represents set A. So option C should be the correct answer. Let's see what is the right answer. Yes, option C is the right answer. Okay, quickly moving to the next question. So let's see one by one. So again, it is related to some intersection, so better to make a diagram so that you can also get a clear understanding. Okay, so we have two set A and B, and this represent A intersection B. Okay, so A intersection B is a subset, or you can say proper subset of A. So A intersection B is a subset of A, right? Yeah, this is correct. So option 1 is correct. A intersection B is a proper subset of B. Yes, you can see this is a part of B also, so this is also correct. A is subset of A union B, so A is subset of A union B. Yes, this is also correct. So with the Venn diagram, you can easily appreciate these options. So all these three are correct. Okay, so option D, those who have given, well and good, they are right. Quickly moving to the next question. Which of the following set is not correct with respect to set A and B? So as I told you, whenever you have such type of question where you need to see every option, always begin with last, option D. Okay, so let's begin with the option D. So A intersection B is 5. So we have two sets A and B, and A intersection B is 5. Basically, if there is no common element between them, they are basically disjoint set. Okay, so no common element between them, so that's why there is no common element, therefore A intersection B, so these are disjoint set. Then either A equal to 5, B equal to 5, this is incorrect. It doesn't imply this, so option D, we can see it is straight away the correct answer. If you go with the other option, let's see option C. So A is subset of B. Okay, so this is A is subset of B. Then B intersection A is equal to A, B intersection A equal to A. Yes, it is correct. So if you see, the intersection means a common element will be only A, so A will be the right answer. So option C is correct, it is not incorrect. Okay, but for they are saying which of the following is not correct, and we have seen option D is not correct, so option D is the right answer. Let's see the next question. Okay, so let's see one by one. You can draw with help of Venn diagram also. Okay, so this is our complete universal set, and we have two sets A and B. Let's make it A and B. So A union B complement. So this is A union B, complement is this white portion. So we have made this intersection with A. You get what? Intersection with A, you get 5. Okay, so 5 minus A minus B is what? So anything which is present in 5 but not in A minus B will be 5. Okay, so option A is the right answer. Okay, understood how this 5 has come? See, A union B in complement, so the complement represent the white portion. Okay, and intersection with A, if you do intersection with this shaded portion, there are no such elements, that's why it is 5. Okay, so option A is the right answer. So that's it. So we have seen almost 8 to 10 questions from operations on set, and I know if you have not watched the conceptual part, it is very difficult to understand for them. Pause the video and have a look on how we solve these questions. Okay, so we have other videos, if you have time you can watch it. So thank you for watching, and if you have anything to say, you can write in the comment box. We will be very happy to answer your questions. Thank you for watching and have a nice day. So let's begin. What exactly is a Venn diagram? Okay, so in set theory, basically Venn diagram are used to show a relationship between set. Okay, so we have already defined what exactly is a set. what are the different operation, what are the different type of set. So in order to relate those set, we need, and to show certain relationship, diagram are always useful. Okay, so there are certain notations, like for rectangle it represent the universal set. So this rectangle represent the universal set, it is denoted by letter U, and the circle represent the subset of U. Okay, basically these are the sets. Okay, circle represent the sets, and in this set you will find certain element, these are called element or member, whatever you can say, and obviously there will be certain element in universal which are not part of set. Okay, so those kind of relation you can put in this Venn diagram, and student, you should know that this Venn diagram are named after English logician whose name was John Venn, who has basically made this relationship diagram, which is also known as Venn diagram. Okay, so let's see one by one different Venn diagram. So as we have covered various operation in the previous session, so like A union B represent this colored portion. Okay, this whole colored portion represent A union B. Okay, this blue portion represent A union B. Okay, I will not define what exactly is A union B. You can watch in the previous session where we tell you everything about union operation. The next is intersection. So there is certain common part between these two set A and B, that is denoted by this symbol, it is known as intersection. This common area is known as intersection area. Okay, it means that this portion belongs to A as well as B. Okay, can anybody tell me what exactly is this A and B represent? Okay, so those who have seen our previous video, they can tell that these are called disjoint set. Okay, disjoint set. Disjoint set means there is nothing common in between them. Okay, so these are called disjoint set, and where we have seen A intersection B is equal to a null set. Okay, so there are no common element between these two. This is denoted by disjoint set. Okay, coming to the other operation like A minus B. So this light shaded blue portion represent A minus B, and we have already seen this portion is known as intersection, A intersection B, whereas the other portion represent B minus A. What does this B minus A? All those elements which are member of B but not of A are in this particular zone. Okay, so these are the four diagrams that you should understand. Okay, and the next formula which I am going to tell you in few minutes, you should learn by heart, student, because these formula are used to solve the practical problem on union and intersection. Okay, most of you already know these formula, but still for the sake of completeness we are telling you. So just remember, there are three finite set like A, B and C, and since there are finite set, there will be a number of elements. So this n represent the number of element in A union B. Okay, so in practical problem you will find certain numbers like there are two classes where the total number is this much. Okay, you need to find the common one, what are the number in set A, set B. All those questions can be asked in the exam. Okay, so the relation is that A union B is number of element in A plus number of element in B minus A intersection B. Okay, this is very important. So A union B means you can think like that. So we have represented A union B like this. So we have completed all the element in A that represent NA. This, the other one, this represent NB, but this shaded portion we have considered two times, so that's why we are subtracting one intersection from that. Okay, so this is how this formula got derived. Okay, and if there is a disjoint set, then there will be no common element. In that case you will have formula like NA plus NB. Okay, so if we have three elements, what would be the formula? This is the formula. So if you have 3 elements, 3 sets basically, so the formula just remember individual sets, number of element in individual set, then minus A intersection, like you can see from here, A intersection B, then A intersection C, then B intersection C. Subtract the common portions because you have included one extra time. If you make diagram, you can easily understand, and in that you need to add all the elements which are common to all the sets. So this portion basically you need to add, because from these 3 operations you are subtracting one and hereby you are ignoring this portion. So that's why we are adding this intersection portion into that. Okay, so these 2 formula are very important, you should learn by heart. Okay, the first question, and it is on your screen. It is a big question but a very easy one. Okay, student, Venn diagram is very easy topic, and you will find 1 questions from this topic in any competitive examination. Okay, so the question says in competitive examination there were 250 students have registered. Out of this, 50 have registered for physics, 75 for mathematics, 35 for both physics and mathematics. What is the number of students who have registered neither for physics nor for mathematics? Okay, so let's make a Venn diagram. So this is a universal set, and universal set has 250 elements, and there are only 2 sets. Okay, first one is maths and second one is physics. Okay, so out of these, 50 have registered for physics. Okay, so this circle represent 50 and 75 represent the other mathematics. Okay, so this is 75, and 35 students have registered for the both subjects. So this portion, intersection 1, is 35. Okay, so basically how many students who have only physics, let's calculate it. So 50 minus 35 is what? 15. So those students we have only physics as a subject, so they are 15, and the only which we have taken the mathematics, so 75 minus 35 is what? 40. So those who have only mathematics as the subject, so those are 40. Okay, so the question wants the number of students who have registered neither for physics nor for mathematics. So you need to find the blank portion. Okay, you need to complement this universal set, so you need to find this whole region. Okay, so 40 plus 35 plus 15 is what? So if you calculate 40 plus 35 is 75, 75 plus 15 is 90. Okay, so if you want to complement it, so 250 minus 90 is what? 160. Okay, so the option D, those who have given, they are right. Option D is the right answer. So this blank portion represent those who have not registered either for physics nor for mathematics. Okay, let's see the next question. This is a very good one, in fact. So in an examination, 52% candidate failed in English and 42% failed in mathematics, 17% failed in both subject. What percentage passed in the both subject? Okay, so again you need to have the universal set, and this question says everything in percentage, so universal set will have 100%. Okay, and you have 2 sets basically. First one is English, second one is what? Mathematics. Okay, English pass percentage is 52%, whereas math represent 42% and 17 represent who have both failed in maths and English. This is 17. Okay, so again, like previous question, just find out those who have failed only in English. If you subtract it, 52 minus 70, you will have 35% of students have passed in English only. Similarly, only mathematics, it will be 42 minus 17, it is 25. Okay, so since the question says who have passed in both the subject, so passed is this white portion, complement of this universal set. Okay, so 35 plus 17 plus 25 will be 5 at 40, 50, 60, it is 77. So 100 minus 77 is what? 23. So option D is the right answer. Okay, so option D is the right answer. Okay, so since everything is given in the fail percentage, so complement means it is pass percentage. Okay, so option D is the right answer. Coming to the next question, out of 105 students taking an examination, English and mathematics, 80 students pass in English, 75% maths, and 10 students fail in both examinations. So it is basically a combination of two. Okay, so you can do it very simply. Okay, so you take only in one condition, like if you are interested in fail, so take only fail. If you are interested in making the question as a pass, you can make it a pass percentage. Okay, so we will try to see only in fail percentage. Okay, so they have given 80% have passed in English. So how many students got failed? 105 minus 80 is what? 25%. Okay, so I will make the fail percentage. Okay, this is a universal set, so this is pass. So how to make it when the number of student fail? So 105 minus 80 is what? 25. Okay, so this is English. So in English 25% of student got failed, whereas 75% student passed in mathematics. So how many students got failed? 105 minus 75. 105 minus 75 is what? It is 5 minus 5 is 0, 30. So 30% of student got failed in mathematics, whereas common region is 10%. Okay, now it is similar to the previous question. Okay, and if you calculate how many students failed only in one subject, like it is 25 minus 10 is 15, and 30 minus 10 is 20. It is 20 plus 15, that is 35. So option C is the right answer. Okay, let's see the next question. Again, a very simple one. In a school, 30 teachers who teach mathematics or physics. Of these teachers, 20 teach mathematics, 15 teach physics, 5 teach both. The number of teachers who teach maths, only a very simple one. We have seen 2-3 questions of this type. Okay, so like 20 teachers are mathematics, so mathematics, this is physics. Okay, so how many? 15 were physics, and 5 teaches both maths and physics. Okay, he is interested in only in mathematics. Only in mathematics is what? 20 minus 5. 20 minus 5 is 15. So 15 is the right answer. Okay, these questions are very easy. But if you see this question is very tricky one. It is a lengthy one, and it is very difficult to solve with Venn diagram because it has 3 variables. So whenever you find 3 variables, always use the formula for union of 3 sets, like A union B union C. So we have seen the formula for this one is like number of element in present in A, in B, in C, then number of element which are common in A intersection B, similarly B intersection C, and these all are additions, plus C intersection A, these are all minus not plus. Okay, intersection part is minus, and finally you have intersection of all these 3 sets. Okay, I am not solving it, it is very easy. Just put the value of the single set, their intersection, and the intersection of everything. Okay, so all values are given, only one X is not given, the number who can speak English and French. Okay, so you can take any set like A intersection B, this is X, and everything is given, and you will find that after solving you will have X is equal to 9 as your answer. What about A union B union C? It is already given, it is 100. Okay, so this will become 100. NA is what? 70, NB is 60, and C is 30, and these intersection is 20, and one is X, and if you calculate it everything, you will find X is equal to 9. So option C is the right answer. Coming to the next question, it is a great question. Let's see who can give the answer. So student, again in a class of 110 students, so universal set is what? 110, and X student can take both mathematics and statistic. So basically there are 2 sets, mathematics and statistic. 2x plus 20 can take mathematics, 2x plus 30 can take statistics. Then no student would take neither mathematics nor statistic. What is the value of X? Okay, so instead of going with the Venn diagram, you can use the formula also. Let's try to solve with the formula. M union S maths union statistic is equal to number of element present in maths plus number of element present in statistic minus number of element present in the intersection of those two sets. Okay, maths is what? It is 2x plus 20, and number of elements present in statistic is 2x plus 30. It is given 2x plus 30, so 2x plus 30, and intersection is basically we need to find the x. Okay, so it is minus x, and 110 element are present. Okay, so this is a simple equation. Okay, 2x 4x, 4x minus x is 3x, 3x plus 50, so you have 3x plus 50 on the right side, left hand side is 110, so 110 minus 50 is 60, 60 divided by 3x is 20, so x is 20, so x is equal to 20, and option B is the right answer. Sometime student, if you use a formula, you will get the answer quickly, since it has a number of variables in it. Okay, so whenever variable is the number of element, you better go with the formula instead of the Venn diagram. Okay, let's see the last question for today's session. And basically this Venn diagram represent, there are 4 sets. Okay, and those who have opted maths, physics, chemistry and electronics, so M maths, P physics, C chemistry and E electronics, we need to tell what is this shaded portion. Okay, so shaded portion has only maths, physics and electronics part, chemistry is not there. So let's see, student who have opted physics, maths, chemistry, so chemistry is there, you can ignore, and chemistry is there, so option C is the right answer. Okay, so you need to find which area it is not covering. So chemistry it is not covering, so the option which have chemistry in it, you just simply ignore that, so the remaining option will be the right answer, and option C is the right answer. Okay.